Alright, for this problem, we have Ash who traveled east at 96 miles per hour. A represents the distance from his rendezvous point to where he ends up. Bart traveled at 28 miles per hour south. B also represents distance from his rendezvous point to the end. And C is the distance between them. And down here we have dc over dt, which is how c is changing in respect to time, like how the distance between them is changing in respect to time. And we get to a squared plus b squared equals c squared because it's a right triangle, and we use this for the rest of the equations. There's a given time in the second part, 15 minutes, which you can rewrite as a quarter of an hour. In order to find A, B, and C at 15 minutes, you plug it into the 96 miles per hour, and you get these. For C, you need to plug in A and B, and then just go through the Pythagorean theorem to find C, which is 25. These are all the given variables. We have everything but dc over dt. We need to use the chain rule in order to find dc over dt, because A, B, and C, they're not in respect to themselves, they're in respect to time. So you can't just do 2a, 2b, 2c. You have to do 2a times dA over dt, because it's in respect to time. You plug in all of your known variables, which leaves you with 5,000 over 50, which supplies down to 100 miles per hour, which is your dc over dt, which is the distance that's changing from A to B. And Bart is able to connect to the van because this is a less than 111 miles per hour, so the van is stable. Okay, for part 3, wrote down all the variables we needed. It's right there in the problem. I'm not going to go through it for the sake of time. Alright, first question asked me to convert 96 miles per hour into miles per second, which I did, dividing it by 60 twice. And that answer is your dz over dt. And it's negative because Ash is getting closer to Ziggy. Question 3 is, why is Moore erased as he goes closer? Moore gets erased as he's getting closer because as this number decreases, you have a bigger number over a smaller number. And a bigger number over a smaller number is larger compared to if you had a bigger number over a bigger number, which would be smaller. So as he gets closer, this number gets smaller, letting this number get bigger. Question 3 asked me to create an expression. So you have the total amount left on Bart's laptop equals the amount stolen minus the amount erased. Question 4, I just wrote R in terms of Z, which is brings you right back up here. Okay, last part here. So first of all, we have the equation T equals D minus what we had for R, but in form of Z. And in order to find what dt over dt equals, which is the change in the total amount of stolen information on Bart's laptop, you have to... Okay, first let's go to what we're given. We have dd over dt, which is 30. That's how much he's taking out per second. Bart is. And then we have dz over dt, which is this. And then we have z, which equals 50. And we know it equals 50 because he's 50 miles away from Ziggy. So in order to find this, first you have to do chain rule for these parts because it's in respect to time. And then for this part, you have to do the quotient rule, which leaves you with negative 5,000 times negative 0.027 over z plus this squared, which z is 50 in this case, 30 minus this in order to find the change. And at 50, it was 29.95 megabits per second, and it's increasing at this moment because the number is positive. And he's also far away, so he's not able to delete as much information off Bart's laptop. When it is 1 mile away, just the same thing, except now it's negative 3.75 megabits per second, which means it's decreasing the amount of information that's on Bart's laptop at this time. And I personally think that they won't be able to get enough information off of his laptop because the amount that he's stealing is so much greater than the amount that they're able to take. And he has to be this close to get this little, like, deleted. Like, he has to be this close for there to be an actual absolute value of, like, negative stuff compared to being 50 miles away. There's more time that this number, where here will be positive, then, or sorry, not this. This is going to be positive more than it's going to be negative because Bart is taking so much at a faster rate. And he has to be so much closer in order to get this negative value.